Hello students, we see metric spaces or metric space. Metric space is the generalization of a real number system with the absolute value function. Now, what is metric space? So definition of metric space is let M be a non-empty set. Instead of capital M, you can take capital X also. A metric on this non-empty set M is a function rho. Instead of rho, you can take D or other symbol also. With domain M Cartesian product M and a range contained in closed, semi-closed, semi-open 0 to infinity, such that for all x, y, z in non-empty set M, we have rho of xy is greater than or equal to 0. First property. Rho of xy is equal to 0 if and only if x is equal to y. Number third, rho of xy is equal to rho of yx. And number four, rho of xy is less than or equal to rho of xz plus rho of z for x, y, z are in non-empty set M. The set M with metric rho is called a metric space. And it is generated by M rho. If rho is metric space, then M rho. If D is metric defined around M, then M D. Or instead of M, if you take R, then R rho or R D. Now here, rho of xy is greater than or equal to 0, and the property rho of xy is equal to 0 if and only if x is equal to 0. These two properties are non-negative properties or positiveness properties. Non-negative. And rho of xy is equal to rho of yx. This property is known as symmetric property. Symmetric property. And rho of xy is less than or equal to rho of xz plus rho of zy. This property is known as triangle inequality. Triangle inequality property. Now for objective questions, so M be a non-empty set, then the property rho of xy is greater than or equal to 0 or rho of xy is greater than or equal to 0. So what is the name of this property? Or rho of xy is equal to rho of yx. What is this property? Or rho of xy is less than or equal to rho of xz plus rho of zy. So what is this property? So you remember the fourth property is triangle inequality. Second is symmetric property. First and second property is known as the non-negative property. So this is the definition of metric space. Now we see one example on this metric space. Now verify that or prove that the function rho defined by rho of xy is equal to mod of x minus y is a metric for the set R of real numbers R rho. So solution. And what is given? You have given the function rho defined by rho of xy is equal to mod of x minus y. Here x and y are belongs to R. And you have to prove that this rho is a metric on R, and R rho is a metric space. And you remember that rho of xy defined by rho of xy is equal to mod of x minus y, and if this is a metric on R, then R rho is a usual metric space. Now verify. Solution. How verify? If here rho is a metric on R, if it satisfies the following properties. First property means rho of xy is greater than or equal to 0. So what is rho of xy? Rho of xy is equal to mod of x minus y, and it is given that is greater than or equal to 0. So this is greater than equal to 0 means rho of xy is greater than or equal to 0. Therefore, first property is satisfied. Similarly, second, what is rho of x y is equal to 0? Rho of, if and only x is equal to y. If x is equal to y, then rho of xx. Rho of xx means mod of x minus x is equal to 0. And rho of yy means mod of y minus y again is equal to 0. Therefore, rho of xy is equal to 0 if and only x is equal to y. Now third. What is third? Symmetric property. Rho of xy is equal to rho of yx. We have to prove that. But what is given? So you have given rho of xy is equal to mod of x minus y. So this can be written as mod of minus y plus x. Or you take minus common, minus 1 into y minus x. And again is equal to mod of minus 1 is 1. So is equal to mod of y minus x. And what is mod of y minus x? Mod of y minus x is equal to rho of yx. Therefore, rho of xy is equal to rho of yx. Therefore, symmetric property is also satisfied. Now we verify the fourth property satisfied or not. Number 4, rho of xy is given. What is rho of xy? Mod of x minus y. So mod of x minus y means you subtract and add z. So is equal to mod of x minus z plus z minus y. Therefore, this can be written as x minus z, then plus z minus y. So you know the properties of modulus, that is mod of a plus b, e less than or equal to mod of a plus mod of b. Therefore, using that, this can be written as mod of x minus z plus mod of z minus y. So mod of x minus z means rho of x z plus rho of z y. Therefore, rho of xy is less than or equal to rho of xz plus rho of zy. Hence, all four properties satisfied for the metric rho defined by rho of xy is equal to mod of x minus y. Here, xy belongs to R. Therefore, rho is a metric defined around R, and R rho is a metric space, and this metric space is called the usual metric space. So similarly, again we see one example. Second example, so that is known as the discrete metric space. Now second example, let R be a non-empty set. Then we define a metric rho defined from R cross to R, and its range is 0 to infinity, defined by rho of xx is equal to 0 for xy, for x belongs to R, and rho of xy is equal to 1 for xy are real numbers but x is not equal to 1. Then verify rho is a metric on R. If here rho is a metric on R, then R rho is a metric space, and this metric space is called the discrete metric space. You remember this. So proof is simple, or verification is simple. What is given? You have given rho of xx is equal to 0 and rho of xy is equal to 1 for xy belongs to R. Here rho of xy is greater than or equal to 0 for any xy belongs to R. Therefore, positiveness property satisfied. Similarly, second property, if x is equal to y, then rho of xy is equal to 0. So this is from 1. From by definition of rho of xy is equal to 0, then it is clear x is equal to y. If x is not equal to y, then rho of xy is equal to 1. Then which is contradiction. Therefore, here rho of xy is equal to 0 if and only x is equal to y. Now, for third property, what is third property? Symmetric property. If x is equal to y, then what is given? Rho of xy is equal to 0. That is rho of x is equal to 0 or rho of y is equal to 0. And so here rho of xy is equal to 0 implies that rho of yx is also 0. If x is not equal to y, here only two cases. If x is equal to y, means x is equal to x. And x is not equal to y. X is equal to y, rho of xy is equal to 0. So we get rho of yx is equal to 0. X is not equal to y, rho of xy is given 1. Therefore, rho of xy is equal to 1 means distance from x to y is 1. The distance from y to x is also 1. Hence, rho of xy is equal to rho of yx for all xy belongs to R. Therefore, symmetric property is also satisfied. Now for triangle inequality. So, for to prove the triangle inequality, so you consider another element in R, that is Z is element of R. Let's consider x, y, z in R. Then, so if x is equal to y, then rho of xy is equal to 0 from definition. And here rho of xz, distance from x to y is equal to 0. Therefore, distance from x to z is greater than 0 and distance from z to y is also greater than 0. Hence, rho of xy is less than or equal to rho of xz plus rho of zy. And also, if x is not equal to y, the distance from x to y is 1. Hence, distance from x to y is equal to 1. Therefore, distance from x to, at least distance from x to z and distance from z to y must be equal to. And hence, distance from x to y is less than distance from x to z plus distance from z to y for all x, y, z belongs to R. Therefore, rho is a metric on R and hence R rho is a metric space. So, in this way, so this metric is known as the discrete metric spaces. Thank you.